In this video, we will talk about how to determine if a matrix is invertible. So we say that matrix A is invertible if the determinant of A is not equal to 0. So let's check out a couple examples. Let's start with the 2 by 2 case. Let's say we have matrix A with values A, B, C, and D. The determinant of matrix A can be calculated using the following formula: A times D minus B times C. So if this value is not equal to 0, then we say that matrix A is invertible. So let's check out an actual example. Let's say we have matrix A with the following values: 4, 5, 0, and -1. How can we determine if this matrix is invertible? Well, we need to calculate the determinant. So the determinant, we said, is equal to A times D. So A is 4, D is -1. So 4 times -1 minus B times C. So B is 5 and C is 0. So 5 times 0. So we get 4 times -1 is -4 minus 5 times 0 is 0. So -4 minus 0 is -4. So the determinant of matrix A is -4. So this is not equal to 0. So we would say that matrix A is invertible. So let's write invertible. Again, since the determinant of this matrix was not equal to 0, this matrix is invertible, or in other words, it has an inverse. Okay, let's try one more example with a 2 by 2 matrix. Let's say we have matrix A with the following values: 6, -3, -8, and 4. How can we determine if this matrix is invertible? Well, once again, we'll calculate the determinant of the matrix. So that is A times D, so 6 times 4, minus B times C, so -3 times -8. So we get 6 times 4 is 24, minus a -3 times a -8, that's a positive 24. So we just get 24 here. So 24 minus 24 is equal to 0. So in this case, the determinant of this matrix is equal to 0. So that means it is not invertible. So let's write not invertible. This matrix does not have an inverse because the determinant is equal to 0. Okay, let's try one more example. In this case, we have a 3 by 3 matrix. So how can we determine if this matrix is invertible? Well, once again, we're just going to calculate the determinant of this matrix and see if it's equal to 0 or not. So there's actually a cool trick that we can use to calculate the determinant of a 3 by 3 matrix. We take the first 2 columns and we rewrite them on the outside of the matrix. So let's start by doing that. So 1, 2, 0, 3, 0, 2. Next, we are going to identify the diagonal values. So there will be 3 diagonals after we've rewritten those 2 columns on the outside. And what we do is we'll multiply each of the values in the diagonals and add them together, and then we'll subtract the product of the values on the anti-diagonals. So there will be 3 anti-diagonals as well. And this is a bit of a shortcut way to calculate the determinant of a 3 by 3 matrix, but it's super useful. So let's do that. So we get 1 times 0 times 6, that's 0, plus 3 times -1 times 0, that's also 0, plus 7 times 2 is 14, times 2 is 28. And then we subtract the anti-diagonals. So 6 times 2 is 12, times 3 is 36, plus 2 times -1 is -2, plus 1, times 1 is -2. Plus, we have 0 times 0 times 7, that's 0. So let's see what we get. 0 plus 0 plus 28, this whole thing becomes 28, minus 36 plus -2 plus 0, that's 34. So we get 28 minus 34 is -6. So -6 is the determinant of this 3 by 3 matrix. And notice, it's not equal to 0. So that means this 3 by 3 matrix is invertible. So we'll write invertible. In other words, this 3 by 3 matrix does have an inverse because the determinant is not equal to 0.